theme is fluorescence for everyone. What do we mean by that? Well, so far fluorescence is used by, I won't say an exclusive club of users, but in a way this is not incorrect. Fluorescence in protein detection and gel electrophoresis is something that is rather expensive, and both consumables and instrumentation is expensive. And that is something that Serva is going to change. And our motto for the next coming months, and maybe year, is to make fluorescence available for everyone. And before we look into the advantages and the details of fluorescent staining, labeling, and detection, I'd like to give you an overview of the different methods that we are using nowadays, the most common methods in protein detection in gels, but also for mass spectrometry, as one example here. The different methods are Comassi blue staining, very widely used, the workhorse all over the world. And when you look at the sensitivity level that I've plotted here, it says 20 nanogram or 5 nanogram. This goes for either the soluble version of the Comassi, that is the Comassi R species, or the colloidal staining using the G species. 20 and 5 nanogram is very low level or very high sensitivity limit for blue Comassi blue staining. In practice, it's rather 20 nanogram for the colloidal and 100 nanogram for the conventional staining procedure. The nice thing with Comassi, however, is it's quite good quantitative, unfortunately only in a very narrow dynamic range. So blue staining, Comassi, brilliant blue staining, can be used for quantification and is used widely for this purpose. Then we have two staining methods. Negative staining, very commonly used for preparative staining, visualization methods, and silver staining. Both are pretty sensitive. Negative staining goes down to around 15 nanogram and silver staining to 200 picogram. However, both cannot be used for quantitative analysis, and they also don't have any dynamic range. I don't want to go into the detail about this. Maybe we have another webinar in the future where we talk about the different staining techniques and methods again. And we come to fluorescent staining very soon, but let me briefly say something about the X-ray film and the phosphorimager plates. This is an elderly technology, in particular the X-ray film, but still it's pretty sensitive, and you can also quantify it over a significant linear range, in particular the phosphorimager plates. The limitation of this method, however, is besides the fact that you of course have safety regulation for the laboratories, but you only can use that for cell culture samples, not for human samples, not for tissue samples, and not for body fluids, for instance. And in comparison to the visualization methods used for electrophoresis, I have also listed here the stable isotope labeling, which is also pretty sensitive, and it's also easy to quantify and has a good linear dynamic range. Now let's talk about fluorescent staining and labeling. Fluorescent staining and labeling works with organic molecules that have as one of their natural specifications the capacity to generate fluorescent light, and this fluorescent light can be detected. The staining version, so that means here you have a classical staining procedure after the electrophoresis. So you do your protein fixation in the gel, then you do a washing, and then you do a staining, and then you do a fixation again, and a washing, and so on. So pretty similar to Comassi staining procedures or some of the silver staining procedures. When it comes to the labeling, that is the process where you put the organic molecule, you have a reaction of the organic molecule with your protein before you do any electrophoretic separation. The difference between the two is that the staining can be done, as I said, after the electrophoresis, so you just stain the separated proteins in the gel after you have washed off all impurities and disturbing substances that might be in your sample. Labeling means that you label everything that can be labeled before you do the electrophoresis. The difference between the two is the much increased sensitivity of the fluorescent labeling, and that the fluorescent labeling is even better for quantification, as a wider dynamic range. The disadvantage of the labeling technology so far was that the labeling reagents were extremely expensive. So before we go into more details of the technology and the offer that we make, I just want to spend some few words on the character and the nature of the fluorescent the light and what happens in the molecule. Why can we utilize the fluorescence detection for protein analysis and electrophoresis? Well, the fluorescent stain is nothing else but an organic molecule that has got the capacity to absorb light of higher energy and lower wavelengths, then absorb the energy from this light beam, and milliseconds or even smaller time amounts later, a light is emitted that has a lower energy and higher wavelengths. And this process takes just very, very short time, and this effect can be used to measure the quantity and the quantity of the protein in a gel. The time here is very short. The time is a fraction of a second. If this time here would be much longer, then we would not talk about fluorescence, then we would talk about phosphorescence. That is something that you can observe in nature, for instance, with the dragonflies that are a very nice insect that lives in the summertime. Okay, so you can separate the two wavelengths very well. So here we have an example plotted down of a combination of the excitation and the emission wavelengths. Excitation in this case would be some 350 nanometer, and the measurement would be done at around 400, maybe 45 nanometer. And you can separate these two wavelengths very well using filters. And that will enable you in a measurement setup to have a measurement of the emitted light that is not disturbed by any kind of light from the excitation or other wavelengths. So you have an excellent signal to noise ratio, and that means that you have a very sensitive measurement setup, and you can therefore measure very low amounts of fluorescence in a gel. And that also means, of course, that you can measure very low abundant proteins. So, talking about the big difference between the staining and the labeling, it's very much not just the increased sensitivity and linear range, it also, when it comes to the practical work in the laboratory, a big advantage. When you compare that to the staining technologies, and we could also say this is the same, not just for Comassi, but also for the fluorescent staining, you always have a protein fixation process, then you have a staining, then a destaining, and then an imaging. So we talk about a couple of hours work after the electrophoresis before you can do the image capturing. With silver staining, it's even a process with many more steps, and I mean, for those of you who are doing silver stain, I don't need to mention, but there are silver staining protocols available that have up 30 or even more different steps, very time consuming, a lot of work. Labeling makes life much easier. You label before the electrophoretic separation, and then you can do the imaging straight ahead directly after the electrophoresis. So that brings this entire process down from a couple of hours to the time it takes to do the electrophoresis plus 30 minutes for the labeling reaction. That means with short and quick electrophoresis, you might have the information available even within a little bit more than 1 hour. So we have launched a dye that we call Lightning Red. That was already in 2013, and since then many users have tried it and found out that it's extremely easy to use. The labeling reaction, so the reaction between the dye and the protein, is very stable and very robust. Robust means that it's not affected by other chemicals. You just need a dedicated pH. I will talk about that in a minute. So the advantage are that you have a direct detection after the electrophoresis, no staining and washing steps after the run. It's very sensitive. We have detected here a lower detection level of 0.5 nanogram for bovine serum albumin or 100 picogram per spot in a 2D gel. Remember the table that I showed to you, 100 picogram is the very lower level of high sensitive silver stain. It has a wide dynamic range, a wide dynamic and linear range, so it's excellent suited for quantification. It has no overstaining effect, so it's insensitive to varying lengths and concentration of the dye, varying lengths of the labeling reaction and concentration. And the amount of the dye doesn't give more intense staining or less intense staining. There's a natural kind of balance of the reaction, so that a dedicated amount of lysines in your proteins is labeled, and this is stable. That means that in practical terms, it has a similar behavior like Comassi, an almost stoichiometric relation between the intensity of staining and the amount of protein in your sample. It's fully mass spec and Western blotting compatible. You can use that, for instance, to check if your electrophoresis was okay, and then directly go to Western blotting and go ahead with your analysis. So the label is not infringing with the Western blotting and, for instance, chemoluminescence process. And last, but definitely not least, following the motto of fluorescence for everyone, it has a very affordable price. I will not talk about pricing here. Contact us and you will get all the pricing details for the different chemistry and also for the instrumentation. So this is a result that you obtain using the labeling. In this case it was urine samples, and I just will announce that already here. I come to that later in my presentation. This is done with a new generation, the youngest generation of fluorescent detection systems, but I talked about that in a minute. You see here, this is the presentation of a fluorescent detection, and it's converted into a black and white image so that it's easier to compare this to images that we are used to see. I will later show you a result as the system is capturing it. This, by the way, is an application for nephrologists. They apply the urine of patients on the gel and run an SDS electrophoresis just to see where the kidney has got damage and to analyze different nephrologic diseases. So then we come to a staining fluorescence dye, so an organic molecule which has an organic molecule like, for instance, also Comassi. It's also labeling the protein, but it does it after electrophoresis because it doesn't stand the electrophoresis conditions and the electrophoresis run. So this is like Comassi, Comassi done after the electrophoresis. That means that you have fixation, staining, and washing steps after the run, with the disadvantage of that it's time consuming, and the advantage that you have just the proteins in the gel, and you can wash off all the substances that might disturb a proper staining. It's also very sensitive, not as sensitive as labeling is, but still 5 nanogram for bovine serum albumin, or 1 nanogram per spot in a 2D gel. It has got a wide dynamic and linear range. It has no overstaining effect that is similar to the labeling or to Comassi. It is also the Serva purple, the staining dye, is fully mass spec and Western compatible, and again also this fluorescent dye is available at a truly affordable price. Here is the result of a 1D gel. It stains, of course, also perfectly 2D gels, like the other dyes do as well. So also the fluorescent dyes do that. One advantage of the Serva purple definitely is that it's environmental friendly. It's not toxic like many other fluorescent dyes on the market, and it's completely environmental compatible. So you don't need to have special dangerous waste treatment or something. This is a biological molecule originally synthesized in an Australian fungi. So what you see here are different HeLa cell lines and E. coli extract, and you see it's very sensitive and it's easy to do. Here a comparison of the different staining technologies. I talked about Comassi. This is Comassi R250. So this is the soluble Comassi species in organic solvent and water and acetic acid. You know all this. Then we here have an example of silver staining. This is actually done with the Serva silver staining kit. And then we have Serva purple. Again, this is the staining solution after electrophoresis. And here we have Serva lightning red. That is the labeling dye that you label to the proteins before you do electrophoresis. And the difference between the 4 types you can easily see. Comassi is the least sensitive staining method. Silver here is much more sensitive, but silver also has got one effect, that you have an overstaining very, very quickly, and unfortunately silver staining is not quantifiable. So it looks very nice. You can perfectly use silver staining for pattern identification, for very sensitive pattern identification, but unfortunately not for quantification. Then we have Serva purple, which is very good for quantification, and it's at least as sensitive as sensitive Comassi staining, but not comparable to Serva lightning red, which is much more sensitive, and you see it's at least as sensitive as the silver staining, but fully quantifiable. A true advantage. And I can also tell you, not talking about prices, but Serva lightning red is not more expensive than silver staining. All the 4 gels have been separated using this blue vertical electrophoresis unit, a very robust little mini vertical system, extremely easy to handle, but at the same time a very robust build for long-term use, the true workhorse in everybody's laboratory. As I already said, fluorescent labeling is at least as sensitive as silver staining. Here is again an example of urinary proteins. Here you see the silver staining, and here you see the same proteins, the same samples, fluorescent labeled. So the sensitivity here is higher, and when you consider that the staining here takes at least 3 hours working time, and this is 0. After electrophoresis, you directly go into the imaging system. So these horizontal gels have all been separated using our Blue Horizon flatbed chamber. This chamber consists of a cooling plate that is an aluminum oxide ceramic cooling plate, a power supply, and you need a thermostatic circulator for true high performance electrophoresis. Okay, put together the lightning red advantages: direct detection, no staining and washing steps after the run. After imaging, gel can be further processed by Western blotting very, very easily. Very high sensitivity, better than 100 picogram of protein per spot. Wide dynamic and linear range of, and here I have a little mistake, it's 10 to the 5 and not 10 to the 4. No overstaining effects. That means that the proteins that don't become hydrophobic, what you can also often obtain and observe when you label proteins with certain fluorescent dyes. I'm not talking about suppliers or which ones, but this is an effect that you often obtain, that proteins become very hydrophobic when many lysines in a protein are labeled with a fluorescent dye. This is not happen when you use lightning red, and you also don't get a mass shift because it's always the same number of lysines that are labeled in a given protein. And the labeling, and that is a big advantage of the lightning red dye, the labeling is unaffected by carrier amphilites, reductants. pH should be above 8. That is the only prerequisite. And I have shown these urinary protein samples to you because urine is a very special, tricky, difficult to handle and label sample, because in pathological urines you have got a lot of different chemicals due to all the medication that patients take and so on, and it's therefore a very demanding sample. And as you have seen, Serva Lightning Red is doing that very, very completely and very easy. And again, it's fully MS compatible, so I guess it's a perfect label. It's a perfect fluorescent workhorse for fluorescence detection. So, and then the question for many, many people is, do we have a budget for fluorescence devices, since these devices are usually very expensive? And we have found a solution for that problem, and this solution is just a small part, or let's say a 7th, an 8th, or a 9th, or whatever, of high cost fluorescence equipment. So we have a very low price offer. Again, I'm not talking about prices, but contact us and we will give you the information. So we are talking about the Serva Blue Imager, a new device that offers fluorescence detection opportunities that have not been available before. This is how the image that the Blue Imager is capturing looks like. So you see this emitted light is detected, and this is the true information, and then it's converted into the other way around. So the background then is white and the bands become dark. That is the more usual way to look at it, but this is the original signal that the machine is capturing. I have said that already, it's more sensitive than silver and quantifiable. And I think that is something I'm convinced about, that this is one of the biggest advantages of this fluorescence technology. It's that we make it available for everyone, and that everyone can also, in the lower abundant area, quantify proteins that has not been possible so far. When I say sensitive, well, you all know the most prominent scanning system on the market, that is the Typhoon. And when you compare the sensitivity of the Serva Blue Imager Actually, in this case, an imager has a price range of 1/8 of what a Typhoon cost, and the result is not 1/8 of the Typhoon result. So this looks very, very promising. This is how the system looks like. It has got a pretty small footprint, and it's also just 30 kilos. So this is something that you can even carry around in the lab. It has, as the capturing device, a CCD sensor, a dynamic range of 0 to 3.6 optical densities, and an exposure time. And this we have improved already now. I think it's 25 seconds. The resolution is 1600 times 1200 pixel. There's a zoom lens built in. The light sources are red, green, and blue for this classical RGB technology, 470, 520, 630 nanometer, and in addition to that, as an extra, you have a white light table for stained gels. It has got an autofocus, so it's pretty easy to handle. 6-position filter wheel, and the system can be equipped with different filters. Usually it comes with 595, 665, and 535 nanometer. Those of you that find this familiar, this is a filter setup for the Dice dice. It has got an 8-inch touch screen, so the entire system is controlled via this touch screen. However, since it's equipped with LAN and also WLAN system, Wi-Fi, you can have the screen to control it also on your netbook, on your laptop, on your tablet, and control it from an external device. Dimensions I've already roughly mentioned, and it comes with a CE certification for the safe of use and so on. Price, I'm not talking about it, but I said it's something that has not been available so far, and detailed information you can always get from Serva. So this is a picture of the white light table that is built in, so you don't need an extra device for your stain gel. You can also do the image capturing using the system. I've shown that to you already, so I can tell you right now that these images, they all come from the blue imager. So it's a workhorse for every laboratory. I just wanted to repeat the silver staining and the capacity of the device and the fluorescent labeling technologies for quantification. You can do 2D electrophoresis. This is an example using a mini gel, one of our precast mini gels. And I don't want to forget one of the most interesting applications, and that is, of course, the fluorescence multiplexing using side-eyes. This was introduced in the middle of the 90s, and it still offers the utmost of reproducibility in quantification, but it used to be, until now, a very expensive technology. Both the capturing device and the dyes have been very expensive. And now comes the device, the blue imager, that can capture the different Psi images like Psi 2, Psi 3, Psi 5. And we have launched new dice set of Psi 2, Psi 3, Psi 5, Lightning, Psi 2, Psi 3, and Psi 5. And this is our offer. It's available already on our website. We have a very interesting price setting for the market introduction. Contact our website, contact us for further information. So at the end of my presentation, I would like to introduce what we have got beside the blue imager, and that is something that is even tinier. This is a netbook, and now you can see how small and how convenient the size of our blue cube is. So far, it comes with a CMOS sensor, and the CMOS sensor had the disadvantages in the past that their resolution was not very good, but they were very fast. And now they combine the fastness and also a higher resolution, so that means that they very quickly give very good and high resolution image for the analysis of gels. In the moment it comes with a UV table, but we also work on a model with a blue light table. The area is ideally suited for mini vertical or also agarose gels. It comes with a magnetic UV protection shield, so that is attached to the unit, and you can easily then do the preparative work, remove bands from a agarose gel and so on. It comes with a filter holder for ethidium bromide. That is something we will develop further, and here you will get more information in the future about the development of very interesting, convenient, and also affordable tools for UV and fluorescent detection. So here's an image. This has been stained using the Serva DNA Stain Clear G. This is something I just want to introduce very briefly to you. This replaces ethidium bromide with the clear advantage. It's non-toxic. It doesn't change your DNA information, and you also don't be forced to handle the waste in a very special way. This is biodegradable, and you can just pour it in the sink. So, fluorescence for everyone. This is our promise. There will be more to come, and we would be very delighted if you join us for another webinar in the future where we can introduce what we have then developed and offered in the meantime. I thank you very much for your interest, and if you have got some questions, write it down and we try to answer the questions straight ahead. Thank you very much, and meet you soon. Bye-bye.